Okay, so now we're here with rotational symmetry. So we had reflectional symmetry, now we got rotational symmetry. A figure has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less, 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 by a rotation of 180 degrees or less. For example, a square has 90-degree rotational symmetry because a rotation of 90 degrees maps the square back onto itself. So here's a good little example. Like if you rotate it 45 degrees, yes, it's still a square. Some people think this shape is a diamond. No, still a square, it was just rotated 45 degrees. But notice how it's not oriented the same way. Do another 45 degrees and boom, now it has the same orientation. It looks the same as before. All right, so there's no real formula, there's no real trick. You just kind of have to use logic and stuff, right? So for each figure below, determine the rotational symmetry that exists, then find a rule to determine the rotational symmetry. All right. So what I like to say is, well, first off, actually, let me rewind it a little bit. And at full spin, there's 360 degrees. All right, we're always working with 360 degrees and going from there. Now, in this Venn diagram, notice how there's three most outer points. Well, if I rotate the outer points, well, I could rotate it there, jumping a little bit, and there. I have three options. All right, since there's three options, I'm going to take 360 and divide by 3, and the rotational symmetry for this is 120 degrees. That means if I rotate this 120 degrees, the figure will look the same exact as it does right now. That's it. Here we got the gear. Well, boom. If I rotate the teeth just to match up, well, how many teeth are there? How many options do I have? All right, I have 1, 2, 3, 4, 5, 6, 7, 8. All right, I could rotate it there, 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 so on and so forth. Very exciting stuff. All right. So there's 360 degrees in the full spin. I have 8 options where to land. 360 divided by 8 is 45 degrees. All right, this is our good friend, this goofy looking square with the design. Remember, this had no reflectional symmetry. None. Nada. Did not exist. All right, however, if I rotate this 180 degrees, it works. All right, so that was just, I could rotate it. Have to make those sound effects. That's why it's 180 degrees. And then we have this kite. Well, I can't just go bloop. That's not enough. Seems to me like the only way to do this is a full spin. All right, so 360 degrees divided by 1. The rotational of the symmetry for this is 360 degrees. Wait a second. By a rotation of 180 degrees or less, by a rotation of 180 degrees or less, by a rotation of 180 degrees or less. All right, it has to have 180 degrees or less. 360 degrees is not considered rotational symmetry. Why? Because then everything would have rotational symmetry. We want to be more special. All right. There is no rotational symmetry for this guy right here. There ain't none. All right. So what I want you guys to do is below there's some shapes, and we're gonna figure out the rotational symmetry for each of these shapes. So what I want you to do is just trace again. This is gonna be pretty quick, but I want you to make it look better than this. And then you can copy it, and then look how I can, oops. Then I can rotate it and play around with it right there, all right? So take your time. I want you guys to try this. Yeah, I want you to try it on your own. All right, discover the rotational symmetry for each of these objects. And then I'm going to write the answers down, but I hope you just don't copy them. But this, I hope you can figure out why it's this for each one. All right, and then below I want you to draw an object that has 60-degree rotational symmetry. See if you can figure that part out. All right, this is a fun little investigational activity. All right, and then we got some canvas problems to knock out. This looks like a bunch of fun. Ooh, Bowser, so scary. All right, knock these notes out and have a good rest of your day.